with chapter 2.6, example 4, the distance traveled by a ball rolling down a ramp is given by this function, s of t equals 4t squared, where t is the time in seconds after the ball is released and s of t is measured in feet. So again, we get an equation here, and they give me a complete description of what the variables in that equation represent. Okay, so anytime you're looking at a problem in this chapter, when they give you any type of an equation, make sure you read through the chapter or through the problem to make sure that you have a complete understanding of what the variables represent. So there's a ramp, I've got a ball, I let go of the ball. As I let go of the ball, that's time 0, and then as it rolls down the ramp, time passes on. The distance it travels is s of t in feet. And we want to evaluate the average velocity of the ball for each time interval. So if we consider this, that t is seconds, and s of t is feet. If I do a change in y over a change in x, I'm going to get feet per second, which is velocity, right? When it says average velocity, that's a fancy way of saying find the slope, all right? Because if you find the slope from this point to this point, that'll be the velocity of the ball, the average velocity of the ball, from 3 to 3.01 seconds. The distance it traveled divided by the time it took. All right, average velocity. All right. The instantaneous velocity is the other thing we'd be looking for in this problem if we were in calculus. That would be how fast was it going at 3 seconds, or how fast was it going at 4 seconds. So we can find average velocities. How fast was it going on the average from 3 to 5 seconds? It's going faster, of course, at 5 seconds because it goes down the ramp. Gravity's pulling it faster, right? But the average velocity over the time interval is going to be whatever it is, and we can figure that out. But to get instantaneous velocity, that's a calculus thing we're going to do. So again, pre-calculus class, preparing you for calculus. We'll do the same type of stuff in calculus, but then we'll use the results to interpret and figure stuff out. So first thing I want to do is figure out the answers to these times for this function. It's 4 times t squared. Since I'm evaluating several, I'd probably use my calculator. Probably should have done this while I was talking about other stuff. Now we've got to wait. Alright, so I'm going to put 4x squared as my function. I'm going to go to my table, and I'm going to put in those numbers. 3.01, 3.01, 3.5, 4, and 5. One thing I'm going to caution you about when you're doing problems of this variety, don't round in that chart. I want every decimal that shows up. If there's 20 decimals showing up, give them all to me. This rounds. To find the unrounded versions, you can just go over here. It shows at the bottom. All these whole numbers, of course, aren't rounded. 3.5 is still 49. That's actually 36.2404. And then we got 36. So the only rounded number was that 36.24. So again, if I just highlight that down at the bottom, it gives me the unrounded version, or as much as will fit on the thing. So if there's, I think it goes about 13 or 14 decimal places. So if I record my results here, I got 36, 36.2404, 49, 64, and 100. I'm going to have a good memory because the calculator disappeared. But that's the numbers we have just to verify. 36, 34.2404, 49, 64, 100. So that's task 1. Establish where it was at whatever time. Then, to do my average velocity over the time interval from 3 to 5. This is a time interval, so this is about time. T equals 3 to t equals 5. How far did it go? How long did it take? That's basically what we're doing. So the average velocity is going to equal 100 minus 36. That represents how far it went. Over 5 minus 3, that represents how long it took. 100 minus 36 equals 64. 5 minus 3 is 2. So that ends up being 32 feet per second. Okay, that doesn't mean it's going 32 feet per second in 3 seconds or 32 feet per second in 5 seconds. It just means the average velocity is 32 feet per second. Okay, next one, from 3 to 4. So from 3, starting at 3, ending at 4. So V is going to equal 64 minus 36 over 4 minus 3. That's just going to be 28 over 1. second. Next we have from 3 to 3.5. So from 3 to 3.5. So our velocity is going to equal 49 minus 36, how far it went, divided by 3.5 minus 3, how long it took. So we went 13 feet in a total of 0.5 seconds. 13 divided by a half is equal to 26. Divided by half, the same as times 2. So, finally, time interval 4 there, we're going from 3 to 3.01. So the velocity is going to equal 36.2404 minus 36 over 3.01 minus 3. That comes out to 0.2404 divided by 0.01. If I just slide both decimal places 2 spaces to the right, it's going to make 24.04 feet per second. Relating this to what you're going to do in calculus, what we're doing here is called limiting. Okay? We're limiting the distance between the time we care about and another time. So the 2-second time interval is a pretty wide time interval. We got it closer to 3, got it closer to 3, got it closer to 3. As we continue to get really, really, really close to 3, the average velocity is going to get closer and closer to the actual velocity at 3, which would be 24 feet per second, would be the exact velocity at 3. Okay, that's what calculus is going to go on to do. We're going to get really close, like 3.001 and 3.0001. I probably wouldn't even started with these. I would have started with those, probably, and gotten in really, really close. And the numbers are getting closer to the answer. So 32, 28, 26, 24.04. If you got in at 3.001 and so on, you probably get 24.004, 24.0004, and you see it's kind of getting towards that number. So that's what we're going to do with next year in calculus. But again, for now, that's all we're looking for. I want to say the homework question involving this has some other stuff going on in it. I just want these answers when you get to the homework problems in this section. I want to say there's an E and an F also. Just give me A, B, C, and D. Give me the average velocities. That's what I care about at this point.